Morning. You all hearing me?
Yes, sir.
Yes. Let's give them a couple of minutes to come in, right? All right. So there's only 4 of you all here, but let me try to start, right? Now I want you all to be talking, so let me put you all to the side here. All right. So the topic we was doing all the time is trigonometry. Unless you all didn't understand. right? In trigonometry, we deal with two different types of triangles. Right angle triangles and non-right angle triangles. Right, so right angle triangles have the 90 degrees here. And there's only two formulas we could use, right, for right angle triangles. Oops, undo that. It's a right angle triangle. So this is A, this is B, and this is C. All right. In a right angle triangle, the opposite for the 90 degrees is always the hypotenuse. You understand that part? Yes or no?
Yes, sir.
All right, cool. So opposite here will be common B, opposite here will be common C. Yes or no?
Yes, sir.
Anybody else other than William?
Yes, sir.
All right. Now they have two formulas we could use
Yes,
for
sir.
trigonometry under the right angle triangle. So this is your right. Right, so right angle triangles, right? So under trigonometry, there's only two formulas we could use. The first one is Pythagoras Theorem. P-Y-T-H-E. Oops. Theorem.
So, student, say for time, please.
Okay. Yeah. Who?
So, a student asked if they're waiting in the waiting room.
Okay, let me see addition. All right, no problem. Yeah. So Pythagoras Theorem. What's the formula for Pythagoras Theorem? Anybody remember?
So, I think it's somewhere cosine or something like that.
No. So you see, that's the problem. We had to learn the formulas, right? So we're trying to find out what's the problem, why we not understanding it, right? So Pythagoras theorem says, and I wrote this down for you all word for word, that the hypotenuse squared, which is this side here, so the hypotenuse squared is equal to the sum of the other two sides squared. So b squared plus c squared, right? So this side, which is the longest side, squared, is equal to the squares of the other two sides when you add it up, right? And then the second rule we could use, right, is the trigonometric ratio. What is the trigonometric ratios? Anybody remember what was the trigonometric ratios?
No, sir.
No, sir.
No? All right. What is SOHCAHTOA?
So, fine.
So SOHCAHTOA, the trigonometric ratios are SOHCAHTOA. So sine
Sine
the angle,
over
that angle
hypotenuse.
here, is the opposite over the hypotenuse. Cosine the angle, or cos the angle, sorry, is equal to adjacent over the hypotenuse. And then tan the angle is the opposite over the adjacent, right? And from the diagram, if this is the angle, which one is the opposite? The one that is across, right? So opposite. And the one that next to is the adjacent, right? So what I'm seeing so far, let's say that I don't understand is that I not one, I not remembering the formulas, right? We're not even dealing with how to apply the formulas as it. You have to remember the formula first, right? So for right angle triangles, cancel that. That's no. I should move this thing a little bit neater here. Yeah, so for right angle triangles, these are two things you have to learn, right? Pythagoras theorem and the trigonometric ratios. When do you use Pythagoras theorem? We use Pythagoras theorem when no angle is given, and we want to find one side, right? No angle is given, and we want to calculate the value of a third but a twice side, right? When we use trigonometric ratios, when it have two times. One, when two sides are given and we want to find an angle, and the second one is when one angle and one side is given and we want to find the find the corresponding, it had to be corresponding side. I'll find the third side. All right, so Pythagoras theorem again, and it doesn't have to be the same letters you could use. You could use any letter. So if the triangle was like this, and we flip it over to another side, rotate it another way. All right, if it was like this, and they tell us the triangle now is P, Q, R, we would automatically know that the right angle is here. So therefore, this is the hypotenuse. Opposite the point R is common R, opposite the point P is common P. And we could write the formula. Anybody could write the formula in terms of P, Q, and R for me for Pythagoras theorem? Anybody? What is Pythagoras theorem again? The hypotenuse squared is equal to the other side squared, sum of the other side squared. So which one is the hypotenuse here? Right? So the hypotenuse squared is equal to the
P
sum.
squared.
So P squared plus R squared.
R.
R squared.
R squared.
Right. What's another way of writing this without writing hypotenuse? What letter we could have used instead of hypotenuse? I hear somebody say something there.
Sati?
Who?
No, man.
All right. What side does hypotenuse represent?
Cosine.
No, we're not doing that. No, it's cosine and thing yet. What side does it represent? Opposite Q will be what?
Common Q.
Common Q.
Okay, that's right. Common Q is equal to
Uh,
squared plus R squared. What's another way of writing it? Anybody? Think about it a little bit. What's another way of writing it instead of writing the hypotenuse? Think about it in terms of vectors. This side here.
To the gradient.
Wow, Mark. Wow, Mark. We're not dealing with nothing called gradient and thing, Mark. This side here is from P to
R.
So we could call it PR. Yeah.
Yes, sir.
So instead of writing Q or hypotenuse, we could have say PR, the length of PR squared is equal to P squared plus R squared. Is the same thing. So all these three equations is the same. What it did differently, right? Or what I did differently is write the letters differently or use the different terms that represent the same thing. So yes, this side is the hypotenuse. So we could use this. If they didn't tell us the hypotenuse, we could use the letter, right? If they didn't give you the letter for the opposite side, we could use the length of the line or the vector line P to R or R to P is the same thing. All right. We'll go over that one more time.
Yes, sir.
Yes, sir.
Let me change the diagram. All right. So we know here is the right angle, yes or no?
Yes, sir.
All right. Let's call this L, M, N. So we want Pythagoras Theorem. Oh, I spelled it wrong. Pythagoras Theorem. All right, so you want Pythagoras Theorem. What do we call this side?
So the hypotenuse.
All right, is the hypotenuse. What else can we call this side?
So L, common L,
Come on, L. What else can we call this side?
N and M,
NM, very
and M, sorry.
right? Or MN, sorry, substitute the other way around. MN. Right? What do we call this side?
So the opposite.
It's not the opposite. We don't have an angle.
Common M.
Come on, M, good. What else we could call it?
L, LN,
LN, right? And here now,
Common N.
come on, N or,
LM.
L,
right?
or L.
So what does the formula Pythagoras theorem state again? The hypotenuse squared is equal to the other two sides squared, right? Now, in terms of L, M, and N, I want you to tell me what Pythagoras theorem is.
So what you mean?
In terms of the letters that given for the triangle, rewrite the formula. So I put the hypotenuse squared is equal to A squared plus B squared, but in this triangle, we don't have A, we don't have B. We have L, M, and N. What is the formula that we're supposed to write?
So it could be L squared.
Common L. Don't forget to say common L. Right?
Squared is equals to n squared
N squared, right?
plus m squared.
M squared. Now it doesn't matter which, if you put either one in front, right? It will still
Okay.
look like the same thing.
So the n and the m supposed to be capital, or it's supposed to stay as common?
All right, so once we deal with sides, right, it's common letters,
Okay.
right? Pen given trouble just now. Common, right? And once you're dealing with angles, right, we do capital. Now, if we're dealing with sides in terms of points, right, we deal capital as well, right?
Okay, so
So if you were using the points, not the common letters, we could say, all right, so LM is the same as MN, so MN squared. And because it have two terms, you have to put them in brackets, right? N now, common N is LM, so LM squared, add, and the other side will be LN, sorry, squared. So it's the same thing, just what they do is as they change up the letters, right? We're not changing the formula, this is the actual formula, we're just writing it over in our own letters, right? So they could change the letters on you, but they cannot actually change the formula, and it's the same working, right? Now, let's see if I can strong this out more. So, right. Now for trigonometry, if we have a triangle and we call it A, B, C, and we know it's a right angle triangle, and we call here the angle theta, right? What do we call this side here? The longer side.
Hypotenuse.
Hypotenuse. And what do you call this side here?
say the opposite.
The opposite.
Opposite.
And what we call this side here?
Adjacent.
Adjacent.
Right. Now, for those of you who don't understand why it is opposite and why it is adjacent, somebody could explain to them why it is opposite, why we call this side the opposite.
So it's the opposite because it opposite the angle.
Very good. So it's opposite the angle we're talking about, right? Now, and this here adjacent is because it's next to the angle, right? What about if we change it up? The hypotenuse will always stay the hypotenuse, yes or no?
Yes, sir.
Right.
So,
So if we change it up and we move the angle here now, let's call it alpha, right? What will be this side here,
The opposite.
right? And here will be the adjacent, right?
Yes, sir.
So I understand that part side. Okay.
Yeah.
Now if I say this is the angle, this is the hypotenuse, and I want to find this side, which formula would I use?
Say it say what you say.
Okay, so if I was given the angle and I was given the hypotenuse and I asked to find x, which formula would I use?
So so would use
So the third one?
The third one, which one is the third one? We're counting 1, 2, 3 here. 1, 2, 3, like that.
fine.
And Mark?
Yes, sir.
Nah, not the third one. Why? All right, so let me explain to Mark why is not the third one. We given a hypotenuse, right, Mark? you're given the angle. What does they ask us to find? They ask us to find the adjacent. So which one
Oh,
uses
first
adjacent
one.
and the hypotenuse?
Oh,
Oh,
adjacent
yeah.
over hypotenuse.
Right, so that's cos,
Oh,
right?
That's right.
Is the adjacent over the hypotenuse, right? So that's how we figure out which formula to use. All right, so we change it up a little bit now. That's now taking a little while for me to all right. So if they give us x and y and tell us find the angle, which formula are we gonna use? Let me say this is 5 and they say this is 10. Right? And they want us to find the angle. What formula are we gonna use?
so we will use
So you
sine
sign
Very good. Sine. Why? Because here's the opposite to the angle.
opposite
and
Here's
here's
the
and
the
then we add the
hypotenuse, right?
hypotenuse.
So which formula uses opposite and hypotenuse? Sine.
sign.
All right. All right. What about if they give us here's 5 and here's 3 and here's x? What formula are we gonna use?
So tan.
No.
So we go use cos. We gotta give
No.
it the adjacent.
So tan.
All right. The marks are one thing. Where the angle is.
No way.
Exactly. So what formula are you gonna use?
None.
Pythagoras theorem.
Oh, I know
It
Oh,
have no
sure.
angle, so you
angle.
must use that.
Right. So what's Pythagoras theorem in terms of x, 5, and 3?
So that will be that's not common A.
All right. All right. Yeah, that's not it. Let me just undo what I was doing there. All right. Come on. A.
Square
Uh-huh.
equals to C square plus B square.
C squared plus B squared. All right. So what she did, right, is that she put the common letters. So this will be A, here will be B, and here will be C, right? Now, what I was going to write was this. X squared is equal to 5 squared plus 3 squared. Now, what she said is not wrong. She gave me the formula, right? I started to fill it out. So you see, what the problem is not the formulas. The problem is applying it. So we had to learn to apply it clearly. We see how easy it is to trick all you. All the time I'm showing all you an angle with two sides, and I just erase the angle and give all the two sides. And I'll forget what we was just doing with Pythagoras theorem. Right? So let me go again. What I'm gonna do with this video, right? I'm gonna save this video and I'll put it up on the internet for later watch it, right?
Yes, sir.
So I could go back and watch it again when I get some time. Right. So let me try another triangle. I'm gonna flip. Right. So we calling this X, Y, Z. So we know here's a right angle. So if they give us this side here, let's call it xy, and they give us this side here, y, z, and they want us to find this angle. What formula are we going to use?
Pythagoras theorem.
No, Mark.
Or
No.
trigonometry.
No, Mark. Mark. See this note here, Mark? I want you to pay attention. When no angle is given or shown, we use Pythagoras theorem. Right? So automatically we given an angle or shown an angle. Can we use Pythagoras theorem, Mark?
No.
Good. So scratch that from your mind. What is the other set of formulas we could use? So, ka,
Wow.
wa. Right?
So we using sine.
No. Why? Because the hypotenuse is not given. This is the hypotenuse. It's not given.
So it will be
The
tan,
tan.
Tan.
opposite and adjacent.
All right. So which one is the opposite and which one is the adjacent?
So the opposite is yz and the adjacent is xy.
Now remember, when we're using points, it's still a length that we're using, right? So this is x, y, right? So if we was to use common letters, what we would have used? Here would have been common x, and here would have been common z,
Z.
right? So it would have been tan theta is x over, sorry, yeah, x over z. So it's the same thing. All right. I feel like I gotta start back this class because I really want to go through the full thing with all you. All right, Mark. If they tell me here's 5 and here's 6, find the angle. What formula are we gonna use?
It's fine. So they give it the answer. So you're going to use cosine.
Cosine. Very good. Because why? This is the adjacent and this is the hypotenuse, right? So Mark understand that part, you know. So Mark had to stay quiet for a little bit. So if they give me the side 10, tell me the side is 8, I want to find here. Come on, Z. What formula are we going to use?
Pythagoras theorem because I have no angle.
All right, very good. And what would be the formula?
So
So
it will
cos
be d
No.
square is equal to 10 square plus 8 square.
Actually, not Z squared equal to the rest. Because this is the hypotenuse, right? Remember, it's hypotenuse squared is equal to the sum, these other two sides squared, right? So 8 squared plus Z squared. So this will be 10, hypotenuse is 10. We 8 squared plus Z squared. And just for solving it case, how are we going to solve it? Because we want to find Z. Anybody? What's the next step in solving it? All right. So silence me not surely. What's the meaning of 10 squared?
10 by 10.
10 by
Which is?
10.
100.
All right. What's the meaning of 8 squared?
8 by 8.
Which is?
64.
Good. Now we don't know the value of Z, so ZYZ is still Z squared, right? If we want to find for Z, what we do with the 64?
minus it from the 100.
right? So we have 100 minus 64,
56. No.
36. Now we have z squared, but we want to find z. What's the opposite of squaring? Square root?
Yes, it's square root.
All right.
Six
So
is
if
the
it's square
answer.
root. Now 6 what, Isaiah?
6 square.
No. 6 squared will give us 36. Is this a length? Yes or no? Yes, because it's a side, right? All sides must have units. So if they tell us was centimeters, we'd have put centimeters. If they tell us was meters, we'd have put meters. Understand?
So if they give us centimeters, no meters, you must put units,
Yes,
basically.
because it's a length. All the thing called us understand the right angle triangles now.
Yes, sir.
Yeah, I understand.
All right, I want to go on to the next side, right? So here we're gonna do. I'm gonna end the class quick and start it back, right? So we could do the non-right
Okay.
angle triangles now.
Yes, sir.
All right, so I'm gonna end the class and start it back.
Okay, sir.